In this video, we'll discuss reference angles and the remaining trigonometric functions. In particular, we're going to determine the quadrants on which each of the 6 trigonometric functions is positive and the quadrants on which each is negative. And we'll use reference angles to find all 6 trigonometric values for a given angle. In order to evaluate the trigonometric function of any angle using reference angles, we'll follow the same procedure that we've already used with the sine and cosine functions. Specifically, we'll start by finding the reference angle formed by the terminal side of the given angle with either the positive or negative x-axis. And once we have that reference angle, the trig function value for the original angle will be the same as that for the reference angle, except for the possibility of a negative sign. And the inclusion of a negative sign is determined by the quadrant in which the angle lies. On the right side of the screen, we have our 4 quadrants, as well as an indication of which of the sine or cosine functions are positive in that quadrant. For example, in quadrant 2, the chart indicates that sine of theta is positive, and since cosine theta is unmentioned, we'll assume that that means that cosine is negative. And we've already seen that this is the case, that sine is positive in quadrant 2, cosine is positive in quadrant 4, both are positive in quadrant 1, and neither are positive in quadrant 3. In order to determine where the other trig functions are positive or negative, we simply use these facts along with the definitions of our trig functions. For an example, let's consider the tangent function in the first quadrant. We know that tangent is sine divided by cosine, and in the first quadrant, we know that both sine and cosine are positive. And so in the first quadrant, tangent would be a positive number divided by another positive number, and therefore tangent would be positive. We can apply the same logic to cotangent, secant, and cosecant to see that those 3 functions will also be positive in the first quadrant. And so in fact, instead of saying that sine and cosine are both positive, we could simply say that all functions in the first quadrant are positive. So all 6 of our trig functions in the first quadrant will be positive. If we move on to quadrant 2, we know that sine is positive and cosine is negative. In that case, we know that tangent will also be negative because it will be the positive number sine theta divided by the negative number cosine theta, and any positive number divided by a negative number will result in a negative number. The same will be true with cotangent and secant. Both of those will be negative. However, the cosecant of an angle in quadrant 2 will be positive. This is because it's 1 over the positive number sine theta, and the reciprocal of a positive number is also positive. So in quadrant 2, the sine of theta and cosecant of theta are positive, and the remaining trig functions are negative. If we jump to the fourth quadrant, a similar analysis will show us that the secant function, which is the reciprocal of cosine, is also positive, and the other 4 are negative. Again, for tangent, we have the negative number sine divided by the positive number cosine, and that will result in a negative quotient for tangent. Now, in the third quadrant, we know sine and cosine are negative, which means secant and cosecant, their reciprocals, are also negative. However, if we consider tangent, which is sine divided by cosine, that is a negative number divided by another negative number, and that results in a positive number. So the tangent of theta in quadrant 3 will be positive. And the same goes for the cotangent of theta. And so this chart here indicates all of the trig functions, all 6 of them, and which quadrants they are positive in. For all other trig functions not listed here, the assumption is that they are a negative in the appropriate quadrant. In this example, we'd like to find all 6 trig functions for the angle -5 pi over 6 radians. We'll start off by sketching the angle in the plane. We know that this is a negative angle, which means it will rotate clockwise, and it will rotate around 5 pi over 6 radians. This is not quite a half rotation, which would be pi or 6 pi over 6 radians. And so we'll end up with an angle that looks something like this, and the terminal side will lie in quadrant 3. Also from this picture, we can see the reference angle is the angle formed with the terminal side and the negative x-axis. And to compute this, we can take pi, the half rotation, and subtract off 5 pi over 6, which is the angle that we're rotating here. Again, the negative is just indicating the direction. And so our reference angle is pi over 6. And so in order to determine the trig functions of negative 5 pi over 6, we're going to first determine them for pi over 6, and then apply the rules based on the quadrant in terms of negative signs. Here are the values for the 6 trig functions for pi over 6 radians. The sine and cosine values are ones that we should know, 1/2 and square root of 3 over 2. And the remaining 4 we can find using the unit circle definitions. For example, the tangent of pi over 6 is the sine of pi over 6 divided by the cosine of pi over 6, 1/2 divided by square root of 3 over 2, and when simplified, that results in 1 over square root 3. Since pi over 6 is the reference angle for negative 5 pi over 6, we know that the values of the 6 trig functions for negative 5 pi over 6 will be the same values with up to a negative sign. And what we have to do here is just determine which of these functions values are negative. The angle here is in quadrant 3. In quadrant 3, we know that the tangent and the cotangent functions are positive. And so we'll leave the tangent and cotangent functions as positive values, 1 over square root 3 and square root 3, respectively. But the other functions are negative. So sine, cosine, cosecant, and secant are all negative in quadrant 3, which is where our angle lies. And therefore, our final 6 trig function values for negative 5 pi over 6 are here. The sine is negative 1/2. The cosine is negative square root 3 over 2. The tangent is positive 1 over square root 3. The cosecant is negative 2. The secant is negative 2 over square root 3. And the cotangent is positive square root 3. If you'd like to try an example like this, try to find all 6 trig functions of the angle negative 5 pi over 4 radians. The answers will appear in just a few seconds. The angle negative 5 pi over 4 is in the second quadrant, which means the sine of the angle is positive and the cosine of the angle is negative. The reference angle is pi over 4, which means the sine will be positive square root of 2 over 2 or 1 over square root of 2, whichever form you prefer. And the cosine will be the negative of that, negative square root 2 over 2 or negative 1 over square root 2. And from that, the other 4 trig functions can be developed. Notice here that the sine and cosecant functions are positive. The other 4 trig functions are negative. And that is all because this particular angle is in quadrant 2. And in quadrant 2, the sine and cosecant functions are positive and the remaining ones are negative.